Okay, those that are in class, can you be able to confirm that the questions are clear? You're able to see the questions clear. I can see Pili, that is A6 Pili. I guess you are able to get me clearly as well. So be able to confirm so that we can start. We delayed a bit due to some reasons, but of course we are here. So we can continue. Okay? So please be able to confirm that you are able to get me clearly so that we can start. As I promised, we are going to go through the past paper questions that is on more concept. Okay? And I promise that we are going to start by learning first. But of course, since we're already an hour behind time, so we might just be able to go direct into our questions. So be able to invite your colleagues, be able to invite your friends. Let us do this together. So be able to share in the groups, be able to share with your friends so that we can do this one once and for all. So please be able to confirm, those that are in class, be able to confirm that you're able to get me clearly so that we can proceed. And the first question is coming from 2018 school certificate. That is the more concept question. Okay. So confirm you're able to get me clearly to your end. Okay, so Pili has confirmed that I'm audible. Are you able to see the questions? Once more, are you able to see the questions? The first question, are you able to see the first question? Okay, so the first question, okay, we can start then. I hope you are prepared. You have a periodic table with you because from time to time, I'll be asking from you. This has to be something interactive. It's not about me. For me, I know the questions, but it's about you at the end to be able to do something. So let us apply what we've learned so far. Okay, so the question reads, calcium oxide is produced by heating limestone following the reaction below. So in this case, the reaction is given. Okay, so Flavor is confirming that you are able to get me. So please get to share also with others. Okay, don't be that selfish. So get to share with others just like I'm doing, yeah? Okay, so here is the first question. Determine the relative mass of calcium carbonate. How do you determine the relative mass of calcium carbonate? Now, in this one, in order to determine the relative mass, I'm sure most of you use this. where you say how many oxygens we have. We have 3. One oxygen, the mass is 16. Then you have carbon in this one. There's 1 carbon multiplied by 12. Carbon has a mass of 12. Then we have calcium, which is 1 multiplied by 1 calcium has 40. So in these 3 times that is 3 times 16. What are we able to find? Should be able to give us 48. So be able to participate as well. I'm currently checking the comments from time to time. So if I ask a question, I'm checking the comment to see who is participating. Okay. So that is 48, and this is 12, and this is 40. So 48 and 12 is 60, then plus 40, this gives us what? 100. So the relative formula mass of calcium carbonate is simply 100. Okay, so that is the answer for this one. The answer is 100. Okay, up to the second question, that is B. Determine the mass of calcium oxide. Determine the mass of calcium oxide produced if 400 gram of calcium carbonate is decomposed fully. Okay, determine the mass of calcium oxide produced if 400 gram of calcium carbonate is decomposed fully. So now the easy way of doing this, please, there are always 2 things that you're going to form a ratio. Okay, the one that you're finding, and of course the other one will have the information given. So here what you're finding is calcium oxide, and you can say calcium oxide. Then of course, if 400 grams of calcium carbonate, so is calcium oxide, calcium carbonate to calcium oxide. Okay, now what are you going to do on this one? You are going to find the relative mass of calcium carbonate, and you treat it as the mass. That is mass to mass, and also calcium oxide, you treat it as mass. That is what you're going to do. So I can just put the information here. So the molecular mass, or the relative formula mass of calcium oxide we found is 100. So I'm going to say 100 grams of calcium carbonate produces what? What about calcium oxide? Calcium oxide, calcium is 40, then oxygen is 16. So this gives us 56. So when 100 gram of calcium carbonate is decomposed, it produces 56 gram of calcium oxide. What about when 400 grams of calcium carbonate decompose? What mass of this one will be produced? So you put X there. You can put any of the letters representing that you do not know, okay, what you're going to produce. And of course, at this point, you can do the cross multiplication, where you are going to multiply 100 multiplied by X, so it will be 100 gram X. Let me just bring it here due to lack of space. And what is important, I guess you are following. Okay, so you're going to have 100 gram X equal to 400 gram multiplied by 56 gram. So divide both sides 100 gram, divide both sides 100 gram. This one goes, and you remain with X. Now here gram and gram goes, 0, 0 goes, so you're remaining 4 multiply 56. And what are you able to find when you multiply 4 multiply 56? Let me hear from you. What is the answer when you multiply 4 multiply 56? What is the answer that you are able to get? When we multiply 4 multiply 56, what is the answer? So you should be able to get 224 gram as the mass of calcium oxide that will be produced. So please pardon me for we don't have enough space here, or we should have said calcium carbonate to calcium oxide. Then we say 100 gram, for the sake of following, produces what? 56 gram of calcium oxide. What about 400 gram produces X? When you multiply, it's going to be 100 gram X. 100 gram X is equals to 400 gram multiplied by 56 gram. Divide 100 gram, divide 100 gram. So for this one, this is X. So for this one, 100 goes. You are remaining with X is equals to, so this, so here you are remaining with 5 multiplied by, 4 multiplied 56, which is 224 gram. Do we have a problem up to this point? Okay, so Pili, you found it correct. That is 224. All right, I guess you are all following. Let us go to the C question. That is the last question on this one. So this question basically is coming from section B. So section B questions, the marks differs. It might be 4 marks, 5 marks, 9 marks. I think the maximum is 9, or below that 7. Okay. I don't understand your method. What method do you know? Pili, what method do you know? What I've used here is called mass to mass. Mass to mass. So this is the easy method if you are given to find the mass. This is the easiest method that you are going to use if you are given the mass. Violet is saying, repeat. Do you have the problem, Violet, on the whole topic or something? What I was trying, let me just go through a little bit, or just once more, but I will not clean up the answers here. So what we are using mass to mass. When you are using mass to mass, you are going to come up with a ratio of what you are finding. The question is, determine the mass of calcium oxide. Surely you know that you're going to find mass of what? Calcium oxide. And from the mass that you're already given, you know that the mass is going to carry the units of grams. So take note, sometimes mass can be given in tons, sometimes it can be given in kg. So you go with the mass that you're given. Now, since you're finding mass and you know the ratio that you're going to form, that is it's between, the ratio will be calcium carbonate to calcium oxide. So you are starting with the reactant, and of course you end with the product, which is calcium oxide. Now, since I said we are going to use mass to mass, so you are going to find mass to mass requires you to find the molar mass in the first part, the molar mass or relative formula mass of what is involved, in this case calcium carbonate. We find the molar mass, which is just 100. Here we had found 100, but this time around we are going to treat it as the mass. So we are just going to add the units of mass in front of it, which is gram. So we are saying 100 grams of calcium carbonate. When it is decomposed, then we find the molar mass or formula mass of calcium oxide, in which it is 56. So we are saying 100 grams of calcium carbonate, when it is decomposed, it produces 56 grams of calcium oxide. Now, in the question we are given that find the mass if 400 grams of calcium carbonate is decomposed. So in this case, we are going to say, what about if 400 grams of calcium carbonate is decomposed? We do not know the mass of calcium oxide, and therefore we put X. Then we work to find the value of X by simply crossing multiply. So crossing multiply, which means 400 here multiplies 56, and of course X multiply 100. So that is what we have. 100 is equals to, which is 100x is equals to 400 gram multiplied by 56 gram. Now remember, our target is to find X. So for us to get rid of, to remain with X here, we divide 100 gram, equal to the other side, we divide 100 gram. So when we cancel 100, it's going to remain with x is equals to this side, gram and gram, one of the gram will cancel, then 100 will cancel with this, 0, 0 will cancel with this 0, 0. So down you are remaining with 1. On top you are remaining with 4, multiply 56, which is 224. But there's gram here, divide 1, which is just the same as 224 gram. Violet, Mwanza, is it okay now? Or have you gotten something at least? So that is how you apply mass to mass. Okay, I hope we are moving at the same pace. So we move to question C. Give one natural and one artificial use of the gas produced in the reaction above. So if I were to go back and look at the reaction, the gas that is produced is simply carbon dioxide. So now, give one natural and artificial. Very important to understand what is natural and what is artificial. So natural, it just occurs on its own in nature, but of course artificial, that human or man can use it for. So carbon dioxide naturally is used by the process of photosynthesis. Okay, so used by plants during photosynthesis. So that is the natural use. Okay, no one is in charge, no man is in charge of the process. This process is natural, it occurs naturally. But what about artificial use of carbon dioxide? So it is used in making what? In making carbonated drinks. So carbonated drinks, if you talk of Zambia, you can talk of Mojo, I think that's one of the carbonated. You can talk of Kung Fu. You can quite a number of carbonated drinks on the market. And also it's used in baking. I guess you know that. So quite a number of uses of carbon dioxide is also used in putting out fire. That is in the fire extinguisher. So these are some of the artificial uses. So we've answered the first question completely. And of course, I guess everyone is satisfied and we can move to the other one. So Smith, where I say natural use for photosynthesis, artificial, fire extinguisher, and carbonated drinks. What I've just said. So perfect. Those are the perfect answers. Let us proceed and look at the second question now. So let us look at the second question. Okay, I guess you'll be able to see. Okay, so please, those who are calling me, those who are calling, you are disrupting the class, okay? Because the moment you call, the network goes, because I'm using the phone as the source of internet. So please, just for a meantime, let us learn without calling. I know I don't know the challenges that some of you are facing, but calling isn't a solution because you are disrupting the class. Could be you are facing challenges with the network. Try to log in, log out. You are going to until it will be fine. Okay, so this question, as you can see, Elena reacted a certain mass of magnesium with 150 of dilute hydrochloric acid. 240 centimeter cubic of hydrogen gas evolved at room temperature and pressure. So there's a condition here, which is RTP. Okay, very important to take note of that. So whenever you are given the condition, just take note of that condition. You might need to apply it at some point. Okay. Construct the balanced chemical equation for the reaction. So I can see already Smith has constructed the chemical equation already. let us just confirm if it will tally with what we are going to write. So what I'm asking you is also be ahead of us, calculate, answer the question so that we can move at the same pace. So in constructing the equation, you are going to take note of what is reacting. So in this case, mass of magnesium oxide, magnesium react with hydrochloric acid. So what is simply reacting here is magnesium metal. And magnesium, you know that is Mg. Okay? You know that magnesium is what? Mg. So please, if my font is not okay, of which I guess it is just okay. So magnesium is Mg. Then of course react with what? So you can put the state symbol here, which is solid. React with hydrochloric acid, which is HCl. And at this particular moment, I urge you to know 4 strong acid and their chemical formulae. That is hydrochloric acid, sulfuric acid, phosphoric acid, and nitric acid. You need to know those. Those are the common ones that you're going to find. Then, of course, this is going to produce, again, under acid, base, and salt. So where this topic becomes challenging because it encompasses a lot of topics. Acid, base, and salt is one of the topics that you apply here. You need to know that when a metal reacts with an acid, what is produced is a salt and hydrogen gas. And of course, a metal which is more reactive displaces the hydrogen, and of course it reacts with the halogen, in this case chlorine. So magnesium has a valence of 2, and of course chlorine has a valence of 1. So magnesium chloride is going to look like this. So this, I should have indicated that the acid is aqueous. Okay, then plus hydrogen gas. Okay, let me see the reaction that we had. So magnesium chloride, okay, plus hydrogen. Is this balanced? Magnesium we have 1, magnesium 1. Hydrogen we have 1, hydrogen 2. Chlorine 1, chlorine 2. So we're just going to put a 2 in front of hydrogen. Is it what I'm saying? Of course, that is what is there. Okay, the balanced equation. So Smith, you've gotten it right. So that is perfect. Okay. Okay. All right. So let us look at B. So the first one we are done, 2 marks. So now listen the way it is with more concept. What makes it challenging? The moment you fail to write the chemical equation or to construct the chemical equation that is correct, the next one you're not going to answer it because it is normally based from the normally you get to calculate the equation that you've constructed. So for B, calculate, that is Roman numeral 1, the number of moles of hydrogen gas or hydrogen in 240 centimeter cubic of the gas. So now, I'm not able to see anyone who've calculated the number of moles. Is there someone who've calculated the number of moles already? You get to share. I'm reading the comments right here. I can only see Smithy's chemical equation, but I'm unable to see the number of moles of hydrogen. Okay, so how do you find the number of moles of hydrogen? So number of moles of hydrogen, you even indicate, so number of moles N. So I'll put hydrogen. How are we going to find it? So that is where now we go back. What is the condition given? So the condition given is that at RTP. And what you should know, or the formula that you are going to use, always start with the formula. You are going to say given mass divide molar gas volume, which is just a volume of 1 mole of a gas. Okay, now here the volume is given in centimeter cubic. If you want to use it the way it is, make sure that you convert the molar gas, the molar gas volume to a centimeter cubic as well. Normally at RTP is 24 decimeter cubic. which can be 24,000 centimeter cubic, if we're to use it in centimeter cubic. Okay, but if you want, you can convert the volume given in decimeter simply by dividing it with 1,000. Then of course you use the molar gas volume in decimeter. So now, what is 240 divided 1,000? What is 240 divided 1,000? So Pili, you've used the one at STP. So 22,400, it will be the one at STP. Okay, so we are told RTP. STP is 22.4, of which if you convert it in centimeter, it will be 22. I guess you've gotten the correction there. So Pili, I'm seeing your answer. You've used at STP. So 240 divide 1,000, you're going to have 2.40. Is it 2.40? So someone should be able to confirm this one. Okay, then divide 24 decimeter cubic. So this is decimeter cubic per mole. Now, some of you have a tendency of just writing numbers. You are not dealing with mangoes that do not have units. You are dealing with chemistry. So when you are writing exams, you are examined based on your understanding of units. That is the more reason that you learn about units, and also how to apply the formula. But some of you just calculate from somewhere, then you put the answers. So even the process is needed. Put unit at all point. You need to follow 3 steps. Write the formula, replace in the formula with correct units. Then of course you can have to substitute to cancel out the units, and finally you find the final answer. Not just the units appearing at the end of the calculations. I think it should not be like that. So that is where most of you lose marks. Now, if we are to divide here, what is it giving us? If we are to divide, what is it giving us? If we are to divide, that is 0.24 divide 0.24 divide 24. I should be able to give us 0. Is it 0.01? Should be able to give us 0.01 more. So be able to confirm this one. Otherwise, it might affect our calculations as we go on. Namakau saying, I'm unable to see. So what you do, Namakau, it might be that you are watching the video at low quality. So there's a point where you get to place, that is on settings, where you can have to look at, to change the quality in short. But I guess afterward, the recording will be clear as we leave. But what we want is you also to, so that we can move at the same pace, I mean. So get to do that. Okay, and perhaps you might need, if you are using a phone, put it in a portrait mode or full screen. The words might be small. If you are just watching dialect like that, I guess that one should be able to resolve the problem. So now, question 2 of B, the mass of magnesium used in experiment to produce gram, or 240 centimeter cubic of hydrogen gas at room temperature and pressure. So we are calculating now the mass of magnesium used in an experiment to produce 240 grams of hydrogen at room temperature and pressure. Now, what are we going to do for this one? What are we going to do? So we are going to form the ratio of magnesium to what? To hydrogen gas. Okay? And the numbers in front is just a 1. So we're going to use mole to mole, of which we are going to find first the number of moles, or we have the number of moles of hydrogen, which is 0.01 mole. So we are going to use mole to mole, where we are going to find the number of moles of hydrogen, magnesium. Then of course we can use the formula, number of moles is equals to mass over molar mass. Then we can find the mass of magnesium. Up to this point, have you gotten that? We are going to use the mole to mole here, and the ratio that we are going to form is magnesium and hydrogen gas. Since we are asked what is the number of moles, what is the mass of hydrogen that was used to produce 240 centimeter cubic of hydrogen at room temperature and pressure. So here, the ratios are 1 to 1. If I look at the magnesium, the number of moles of in front of magnesium is 1, and of course the hydrogen is 1 here. So it's a 1 to 1 ratio. If it's a 1 to 1 ratio, it means the number of moles of hydrogen is equals to the number of moles of magnesium. So therefore, the number of moles of magnesium is also 0.01 mole. But let me just show you, if it was not 1 to 1, let's say in front of magnesium there was a 2. And this all is from the balanced equation. So we are getting the numbers from the balanced equation. So that is the reason why I said if you answered it wrongly, you balanced it wrongly, then you have it, you find, which means even this question you've donated, you are going to score a 0. Okay, so if it was a 2, we are going to say 2 moles of magnesium produces 1 mole of hydrogen. What about 0.01 mole of hydrogen? What was going to be the number of moles of what? Magnesium. So you cross multiply. So you're just going to double the number of moles. I guess you've gotten that part. So now we can go on and find the mass. What is the molar mass of magnesium? Check out on the periodic table. Let me see it in the comment section. What is the molar mass of magnesium? Mg, it is 24. So if we are to find the mass here, making M the subject, we are going to have number of moles multiplied by its molar mass. So we have 0.01 multiplied by 24. And what is it giving us? Someone to give me the answer here. What is it giving us? Of course, it is giving us 0.24. What are the units? Grams. So 0.24 grams of magnesium was used to produce that volume of hydrogen. Okay. So Namakao, you can see now, I guess you've done what I've told you. All right. Is everything okay on this question? Anyone having a problem? So now you should be able, at the end, I think I should be able, let me just, if I can find a space, you need to know the number of moles. The formula is to find number of moles, 4 of them. Number of moles is equals to mass over molar mass. This is what most of you know. Then the other one is number of moles is equals to concentration multiplied by volume. We are going to come back to this. Then the other one, number of moles is equals to given volume over molar gas volume. Then the other one, number of moles is equals to number of particle over the Avogadro's constant. These are the formulas that you need to know on how to calculate the number of moles. You should be able to use these when you are given a question that is asking you to find number of moles. The third one is normally given or is normally used to calculate the number of moles of the volume, because the volume, we do not have, you can't have the mass of the volume unless at a specific condition, and that condition can be RTP, okay, of which the Vm is equals to 24 decimeter cubic per mole. Then of course you have at STP, standard temperature and pressure, the Vm is equals to 22.4 decimeter cubic per mole. So these, you need to know them when it comes to mole concept. Okay. Okay. Then of course, let us go to the third question that we are answering in this one. 8.8 8.0 gram of impure sodium hydroxide. So impure sodium hydroxide, okay, let me just impure sodium hydroxide of exactly 40 centimeter cubic of 2 moles per decimeter cubic of sulfuric acid. We are done what? Prepare a salt. Elena reacted. Okay, I guess we are yet to meet this question. Okay. Write the balanced chemical equation. That is the first part. I guess you've read the statement. Write the balanced chemical equation. So how are we going to write the balanced chemical equation here? Let me see the balanced chemical equation that you've written. Have you written the balanced chemical equation? So please get to invite some more of your friends. Let them come to this platform and let us revise together. So 8.0 gram of impure sodium hydroxide solution reacted with exactly 40 centimeter cubic of 2.0 mole per decimeter cubic of sulfuric acid. Write the balanced chemical equation for the reaction. Include state symbols. So you see what I said? What I said is that you should be able to know the 4 types, is it 3 types of strong acids. So what is reacting here is sodium hydroxide and of course sulfuric acid. So we are going to say sodium hydroxide, which is aqueous, react with hydrochloric, is it sulfuric acid? Sulfuric acid, which is aqueous. And now here you need to know that when a base reacts with an acid, this is a neutralization reaction. Okay, what is formed is salt and water only. And you know that a salt is the compound that is formed when a positive metal, when the positive ion from the base react with a negative ion from the acid. So here the positive ion is sodium and the negative ion is sulfate. Hydrogen is displaced and water is formed. So now it is sodium and sulfuric or sulfate that is reacting. Sodium has a valence 1, this one has a valence 2. So sodium sulfate is written as Na2S4, which is aqueous, then plus water, okay, which is H2O. Now the question is that, is this balanced? We've put the state symbols, yes, but the question is it balanced? Let us check. Okay, so Joseph, your answer in terms of the product, you are missing a 2 after Na. So after Na there should be a 2, and of course I understand the other part you cannot write this properly, but H2O. So your salt is not correct in terms of chemical formula. So let us check. Sodium we have 1, sodium we have 2. So I have a problem here. So you can put a 2 in front here. So sodium we have 2. So sodium is balanced. Now let us look at oxygen. Oxygen this side, these 2 multiply even this. So 2, then plus 4. So oxygen we have 6. What about this side? Oxygen we only have 4 or 5. So what about if we put a 2 here? Putting a 2, hydrogen will be 4, oxygen will be 6. Let us look at hydrogen. Hydrogen 2, then hydrogen here 2, so 4. So hydrogen 4 here. Then what about sulfur? Sulfur 1. Okay, I guess this is the balanced equation. Someone to confirm this is the balanced equation. So a balanced equation is 2. Then we have a 2 in front of water. So a 2 in front of water, a 2 in front of sodium. So PD, you've gotten it right. Okay. All right. So that is the equation. Then construct a simplified net ionic equation for the reaction. Construct a simplified net ionic equation for the reaction. So now, when you are constructing the net ionic equation, you need to make sure that, what do you do? What is in aqueous state is what split, and of course the one that is in liquid form remains just like that. So now, the problem here is most of you do not know how to split these. For example, I'll give an example of sodium hydroxide. Sodium hydroxide is split as this 2 goes to sodium, then this is aqueous, plus 2 also goes to hydroxide, which is negative ion. So some of you just put maybe a 2 in front of sodium, but without a 2 in front of hydroxide. But at times also just the sodium and hydroxide. So you need to make sure that they balance the numbers. They should multiply the ions. So in this case, plus sulfuric acid, that is where most of you face challenges when splitting the acid. So these 2 that you are seeing here, right, hydrogen, it is going to be in front. Then hydrogen becomes the ion, positive ion. But of course, plus what? Sulfate, which is just like this, negative ion. Then of course, after that, you're going to have this sodium. There's a 2 here, so 2N, okay, which is positive, plus, then this one becomes what? Sulfate, then negative, okay, plus, that is H2O. We cannot split water because it's aqueous. Okay, so now we cancel out spectator ions, those that are found on both the reactant and the product. So sodium is found and sodium is found. Sulfate and sulfate is found. So what you are remaining with is a 2 negative plus 2 positive, then of course H2O. Okay, so this is aqueous and all these ions are aqueous. So that is what you need to write. Okay, so Jackson, Chumba or Chumba, that is exactly what I was saying, that is the mistake that you make. I don't know how you arrived at OH just and H2, I mean H positive. But I guess you followed my explanation in terms of the numbers that balances the equation. You should be able to multiply them in front of the ions. I guess you've gotten that? Jackson, have you gotten that? Your answer is just okay, but you did not take into account the balancing. And of course, there's supposed to be a 2 in front of water. You did not take into account the balancing. Okay, so Pili, you have gotten it right, but there's no 2 in front of water. There should be a 2 in front of water. I guess you've taken into account that. Okay. So now, after this question, they are saying, that is C, find the mass of pure sodium hydroxide from the impure solution that reacted with 40 centimeter cubic of what? Sulfuric acid. So what are we going to do? Find the pure. So 8 grams of impure sodium hydroxide reacted with exactly 40 centimeter cubic of sulfuric acid. Okay? So now what we are going to do here, for us to find pure, in pure you already know that is 8.0 gram. Okay? Now find the mass of pure sodium hydroxide that reacted with impure solution of 40 centimeter cubic of sulfuric acid. So we are going to form the ratio of sodium, okay, to sodium to what? Find the mass of pure sodium hydroxide. Okay, sodium hydroxide to sulfuric acid. That is the ratio that we are going to form. Okay, and as you can see from the equations, in front of sodium there's a 2, in front of sulfuric acid there's none. So now, what are we going to do? we are going to find the number of moles of what? The number of moles of sulfuric acid, so that we can use mole to mole. And in this case, it's going to be 2 moles of sodium hydroxide react with 1 mole of sulfuric acid. Okay, 1 mole of sulfuric acid. Okay, what about 2 moles of, what about the moles of sulfuric acid that we are going to find? So sulfuric acid, we can find the number of moles, the volume is 40, and of course the concentration is 40. The concentration is 2. So which of the formula are we going to use? This one. But the volume, we need it in decimeter. So 40 divide 1000 for us to convert it into decimeter. So we have 0, 0, 4. I guess it's 0.04. Confirm? Is it 0.04? Into 40 is 0. Into 400 is 0. Okay, 0.04 decimeter cubic. Okay, that is what we found. That is what we found as what? As the volume. So now the volume, we need to multiply it with the concentration. So multiply this one by 2, and we are going to have 0.08 moles as number of moles of what? Sulfuric acid. Is someone following up to this point? The point that we are finding now, the mass of the pure one. For us to find the mass of the pure one, I'm saying we are going to form a ratio of sodium hydroxide to that of sulfuric acid. Now, from the balance equation, in front of sodium there's a 2, sulfuric acid there's a 1. Then of course we can find the number of moles of sulfuric acid by using the volume and concentration. Okay, and we found it to be 0.08 moles. Then here we do not know. Okay, so now how many moles of, so here we're going to say X moles of sodium hydroxide. Then of course here we have 0.08 moles. We want to find the mass of the pure sodium hydroxide. Okay, then now if you multiply, it's just the same as doubling the number of moles. Okay, so 2 multiply 0.08, what is the answer? I guess it's going to give us 0.16 moles of sodium hydroxide. Is it what is giving us? Okay, how did you get 0.8? Okay, so how I got 0.08, in fact it's 0.08. What I'm saying here, the question is calculate the number of moles of sulfuric, not this one, that is C. Let me just clean here so that we can leave the space here for the question. So we are on to question C. The question is that find the mass of pure sodium hydroxide from the impure solution that reacted with 40 centimeter cubic of hydrochloric acid. So now, for us to find the mass of the impure, in short, in the solution, impurities remained, but the moles of the pure reacted with the sulfuric acid. Okay, so now how do you find it? You are going to form the ratio of sulfuric acid and the sodium from the balanced equation. From the balanced equation, sodium has a 2 in plant, and of course sulfuric acid has a 1. We form mole to mole ratio. 2 moles of sodium hydroxide reacted with 1 mole of sulfuric acid. What about X moles of sodium hydroxide? What did you find as the moles of sulfuric acid? We found 0.08. Now this is where Namakao is asking how did we get it. So how we got it, we used the formula number of moles is equals to concentration multiplied by volume. And by the what we are finding is number of moles of sulfuric acid. And sulfuric acid, we are given the concentration and the volume. The concentration is 2 mole per decimeter cubic. Okay, then the volume is 40 centimeter cubic. In decimeter cubic, we divide it by 1000, which gives us 0.04 decimeter cubic. Then we multiply here 0.04 decimeter cubic. cubic. If you multiply 2, multiply that, is going to give you what? 0.08. That is how we got 0.08. Okay? So now 0.08 moles of sulfuric acid. How many moles of sodium hydroxide reacted? So I said we just multiply these two, multiply that and that. So it's just the same as x is equals to 2 multiplied by 0.08 moles. And what are we going to find? We are going to find, I guess, number of moles of, okay, x is equals to 0.16 moles of sodium hydroxide. These are the pure moles of sodium hydroxide. Now that we found the number of moles of sodium hydroxide, we can use the formula. To find the mass now. Mass is equals to number of moles multiplied by the molar mass. The molar mass of sodium is 23. So, and number of moles is 0.16. So 0.16 multiplied by 23. And what are we able to find? Someone to multiply? 0.16 multiplied by 23. What is the answer? What is the answer? 0.16 multiply 23. I'm getting 3.68. So 3.86 is the mass, so gram is the mass of the pure sodium hydroxide. Have you gotten that? Up to this point, are we okay? Okay, gram. I guess we are at the same pace. So that is the mass of the pure the pure sodium hydroxide from the impure. Okay, so the impure was what? The impure was 8, and of course now the pure is what? The pure is 3.68. Then determine the percentage purity. How do you determine the percentage purity? So percentage purity is equals to, let me just say percentage purity is equals to pure over mixture. So mass of the pure, mass of pure over mass of what? Let me just say mass of impure. That is percentage purity. So here you have 3.68 divide, what was the mass of the pure? I mean impure is 8. Okay? 8.0 gram multiplied by 100. What is it going to give us as a percentage purity? Someone to calculate 3.68 divide 8 multiply 100. What is it giving us? What is it giving us? So divide 8 multiply divide 8 multiply 100. So for me, I'm finding 46. I don't know what you're finding. 46%. So 46% is percentage purity. Do we have a problem? So most of you are finding 46. I can see it. Any problem up to this point as we progress? Are we learning something? Okay. So just confirm if you are learning something as we proceed. Have you gotten something up to this point? Okay, so I can see the participation, at least the PD, John Nguila, and of course Jackson 46, which is progressive. At least people are following. Namakao, yes, very much. Okay, thank you. So let us proceed to look at now the other question. I guess this is the fourth question that we are answering. So for this question, define concentration. So define concentration. That is the first question. Let me see the definition of concentration from you. So just type in first. Those who are typing in first, at least I'm learning something as well. So I'm learning something from you. What is concentration? Okay. What is concentration? So concentration is just the amount of solute dissolved in a unit volume of the solution. Okay. So is the amount of solute dissolved in a unit volume of the solution. So unit volume of the solution. That is what we call a concentration. So is that the amount of solute dissolved in a unit volume of the solution? State the SI unit for concentration. What are the SI units for concentration? So SI unit for concentration, since it's the amount of solute dissolved in dissolved in a unit volume, so it can be in grams per decimeter cubic or mole per decimeter cubic, and this is known as molarity. Okay, so this is popularly known as the molarity. Okay. Then, of course, for the third question of A, that is calculate the mass of potassium hydroxide, that is KOH, that need to be used to prepare 500 centimeter cubic of 0.2 molarity solution in water. Calculate the mass of potassium hydroxide. Okay, so how do we handle such a question? So in order for us to calculate the mass, you are saying calculate the mass. So mass is equals to, you know that it is a number of moles multiplied by molar mass. So which means we need number of moles of potassium hydroxide and we need its molar mass. Okay, so which one do we go for first? We are going to find the number of moles of potassium hydroxide first, and that is by using what is given, concentration multiplied by what? Volume. The volume, don't forget, we need it in decimeter cubic, so divide this one by 1000, which is 0.5 decimeter cubic. The concentration is 0.02. So we are going to have 0.25. If you see M, just know that it's mole per decimeter. So mole per decimeter cubic multiplied by 0.5 decimeter cubic. Decimeter cubic and decimeter cubic cancels. So 0.25 multiplied by 5. What is the answer? I guess people are following up to this point. 0.5 and 0.25 multiplied by 0.25 multiplied by 0.5. What is the answer? I guess this one should be able to give us 0.125. Okay, more. Someone to confirm? Okay, so John, you've just confirmed that indeed that is the answer. So that is the number of moles of potassium hydroxide. But have we answered the question at all? The question is calculate the mass. So now, like I said, mass is equals to number of moles multiplied by molar mass. So number of moles, we have 1.25 moles, but we need the molar mass of potassium hydroxide. So KOH, hydrogen 1, oxygen 16, which is 17 so far. Potassium itself, which is K, it is 39. Okay, so potassium is 39. So which means 17 plus 39. What is the answer? This is 16, 1. This is the 4, 5. I guess it's able to give us 56. What is 39 plus 17? Confirm. So multiply 56. Okay, and please find the answer here. When you multiply 56, that is gram per mole. When you multiply this, what are you able to find? What are you able to find? Are you following up to this point? Are you following up to this point? I guess people are following up to this point. Okay, so Ngwira is saying 7 grams. That is what is giving you Is it true that the molar mass of potassium hydroxide is 56? So people are finding 7 grams. Okay, so Jackson, it is not 7 gram per mole, but just 7 gram. You are looking at mass. So this more and more cancels from 0.125, and you're remaining only with a gram. So the molar mass, the mass is the gram. So when you are given the mass, give the mass of give the units of mass, gram, kilogram, tons, and all that, without putting more. The moment you put a more, you are talking of molar mass. Okay, I guess that is clear. Okay, B question. Okay, so B question of this same one, construct the balanced chemical equation and net ionic equation for the reaction between potassium hydroxide and sulfuric acid. So we are going to start with the chemical equation. So chemical equation, we are going to say potassium hydroxide, which is aqueous, react with, that is, it is reacting with what? Sulfuric acid. Okay, sulfuric acid, which is H2SO4. Okay, which is aqueous. What is it going to form? Like I said, potassium is a metal that is more reactive than hydrogen, so it will displace hydrogen, and this reaction is neutralization reaction. So potassium have a valence, or has a valence of 1, and of course sulfate has a valence of 2 as a radical, so it's going to be potassium sulfate, something like this, then plus water, H2O. Whatever remains is you balancing the equation. This is aqueous. Now if you want to balance the equation, potassium is 2, potassium is 1, so here we put a 2 here. So potassium 2, oxygen 2, 6, hydrogen 2, plus this 4. So in front of this we put a 2. So hydrogen 4, oxygen 6. I guess this is balanced. So this one is just the same as the sodium hydroxide, because in terms of balancing, in terms of numbers, because potassium and sodium, they both belong to group 1. So in terms of balancing, it's just the same. Okay, what about the net ionic? So we split the aqueous, and this one I needed you to see your input. Okay, so potassium, a 2 in front of potassium as it split, positive, plus 2 hydroxide, then of course here we have plus sulfuric acid H2 positive, plus sulfate, which is negative, then of course potassium here becomes 2 positive, plus sulfate, which is S2 negative, then plus H2O. Okay, so like I said, just the same as the one that we had. So potassium and potassium cancel, sulfate and sulfate cancel, so you are remaining with 2 hydroxide ion plus 2 hydrogen ion. Okay, this one results into 2 H2O. Okay, so this is what we are looking for. Okay, all right, so even if you've forgotten the charges, that is pili, I understand, because the typing might be difficult, but the last part is not hydrogen, it's water. Okay, the last part is showing that it's hydrogen, but it's water. You should know that. I guess it's just a typing error. Okay, so we are done with this question. That is, it's the third question, the fourth question that we are answering. Let us go further and answer this question now. I guess we are all at the same pace, and I guess you are also your friends, you inviting your friends, because everyone need to learn. Okay, so when you find the place or the part where you are learning, at least make sure that you share. That is how it works. Okay, so get to invite some more of your friends. Okay, get to invite some more of your friends. Tell them we are revising here. All right, so here is the question now. 2.0 gram of pure magnesium ribbon reacted with exactly 100 centimeter cubic of 2.0 mole per decimeter cubic of hydrochloric acid. The first question is construct the balance equation for the reaction include state symbols. So please, in the case of those that are following and you still have the problem with constructing the equation, right here on my channel, I have the video just dedicated on how to write the chemical equations and how to balance them, radicals and all things that you need to know. So if you have challenges, get to go to that recording and of course go through before an exam. I can assure you that more concept is one of the topics that you're going to meet in each and every exam, and you don't want to lose some marks. Every mark counts. Okay, so construct the balanced chemical equation for the reaction. So we've done this for quite a number of time. Now listen very carefully. This is where the confusion comes in. Whether you are told magnesium pyrrolate, magnesium metal, magnesium ribbon, magnesium, it doesn't change. The formula is still magnesium. Because some of you are going to spend much of the time looking for magnesium ribbon on the periodic table. It doesn't exist. So it is just magnesium. So the same magnesium that you know, don't get confused. That is the same magnesium we are talking about here. Okay, so Mg. So you're going to say Mg, which is solid, reacting with what? Hydrochloric acid. Now look at the reason why I told you that you need to master the chemical formulas for acid. Okay, that is, let me just put them here. Hydrochloric acid, you can write hydrochloric acid, chloric acid. Then of course we have, let me just put phosphoric acid, although this one is not that common, phosphoric acid, but who knows this time around, which is H3PO4. Then of course you have sulfuric acid. So sulfuric acid is one of the acids that you need to know, which is H2S4. Then you have to know nitric acid. So nitric acid is just HNO3. So these you need to know them by heart, because what you are going to encounter is just these acids. Okay, but when it comes to organic chemistry, you are going to encounter also weak acid, of which they are easy. So someone has already written it, which is just a repetition of what we've done already. Okay, so now is it hydrochloric acid? Okay, HCl. So here we've written already this, which is aqueous. So we said is magnesium, then chloride, okay, which is aqueous, reacting with, producing what? Hydrogen gas, which is a gas. It's a metal and an acid. You should know that generally. Balancing it, what did we say? Here, magnesium 1. So we said we put a 2 here. Hydrogen 2, hydrogen 2. Chlorine 2, chlorine 2. So I guess this is a balanced one. Okay, so I can see Jackson, PD, they've written it. Okay. Then let us have, so I can clean this part. Determine the limiting reagent. So something new. Determine the limiting reagent. Now, the limiting reagent is the reactant that is in short supply, or the reactant that finishes fast. And when it finishes, the reaction stops. So whatever you are going to calculate in terms of calculation, you are going to form between the limiting reagent and of course the product. I guess we'll be able to meet such a question, and of course I'll get to explain better. So now back to the question, how do you determine the limiting reagent? So in order for you to determine the limiting reagent, what are you going to do? You find the number of moles of the reactant first. So you're going to start by finding number of moles of what? Magnesium. Now the question is, which formula are you going to use? That depends on the information that you have on magnesium. So 2.0 gram of pure magnesium. So we have the mass. So you're going to use given mass over molar mass. Okay. Then number of moles of hydrochloric acid. What are we going to use on hydrochloric acid? We are given the volume and the concentration. So we are going to use number of moles is equals to, is it supposed to be different? That is concentration. It is concentration is equals to number of moles over volume. So in short, number of moles is going to be concentration multiplied by volume. Okay. So that is the number of moles. I can even put n number of moles of HCl. So these are the formulas that we are going to use. So what is the given mass here is 2.0 gram. Divide what is the molar mass of magnesium is 24 gram per mole. Here, what are we going to find? What are we going to find when we divide 2.0 divide 24? What is the answer that you are able to find? Let me hear from you. So when you divide 2 divide 24, for me it is giving me, what is this number? 2 divide 24. So it is giving me 0.0, is it 0.0? 0.08, I can put 3. So these are number of moles of magnesium. Kindly confirm. Then for HCl, the number of moles, we multiply the concentration, which is a 2 mole per decimeter cubic, multiply by the volume in decimeter cubic. It will be just 0.1 because we divide this one by 1,000. So decimeter cubic. So this one and this one goes. And I guess this one we are able to find 0.2 moles. That is the number of moles of HCl. Let me see what you found. So number of moles, okay, John, so you found it, we found the same. Of course, Pili, also Namakau, the same. Okay, so we are settled. 0.083. That is the number of moles of magnesium. Now, what we've done is just the first step. Now, how do we determine the limiting reagent? So for the limiting reagent, the first step, find the number of moles of the reactant. Then, of course, after you're done that, divide with the number of moles in front of the balanced equation. Those we call them stoichiometric coefficients. So from the balanced equation, what is in front of magnesium? It's just a 1. So divide the number of moles that we found, 0.083, divide 1, of which is going to give us 0.083. Then also for hydrochloric acid, in front of hydrochloric acid there's a 2. So when you divide, it's going to give us 0.1. Now, after you are done with that, or after you've done that, the one with less number of moles is the limiting reagent. The one with less number of moles is the limiting reagent. Okay? So now, Pili, which one is small? 0.08 and 0.1. Which one is small? Because to me, this one is the one that is small. And therefore, limiting reagent is what? Is magnesium, according to our calculation. So magnesium is the limiting reagent. Which one is small? So the one that is small in terms of number of moles is the limiting reagent. So if our calculations are okay, then the limiting reagent, please, is magnesium. Have you gotten that? Okay. Then the last question of this, or I say the question C, calculate the volume of the gas that was evolved at RTP. Calculate the volume of the gas that was evolved at RTP. So, immediately you hear of that, think of number of moles is equals to volume over molar gas volume. We are looking for the volume. So, volume is equals to number of moles multiplied by Vm. And now we are talking of the gas. So, which means number of moles should be of hydrogen gas. Okay? Now, what is the number of moles of hydrogen? Why did I put water here? Should have put hydrogen here. Okay? Just hydrogen, not water, please. Okay? So now, how do we do it now? So now, here, that is where I want to explain something. What we are doing here, calculate the volume of the gas that was evolved. You know that the gas that was evolved is what? Hydrogen gas. So we are going to make a ratio of one of the reactant and hydrogen gas. But the question is at which reactant? We are not just going to get any of these just anyhow. We need to pick. Now, which one are we going to pick? So this is where you need to know this now. Normally, you pick the limiting reagent. Have you gotten that? Normally, you pick the limiting reagent, because when it is done, then the gas cannot be produced anymore. So don't make a mistake of forming a ratio of the excess reagent to that of the product. So it is always the limiting to the product. So we're going to form the ratio of magnesium to what? Hydrogen gas. So 1 mole of magnesium produces 1 mole of hydrogen. So this is what mole to mole, and this is 1 to 1, which means the number of moles of magnesium is equal to the number of moles of hydrogen. It's a 1-to-1 ratio. So therefore, number of moles of hydrogen gas is equal to the number of moles of magnesium that we found, 0.083 mole. So we have the number of moles. Then we can now multiply. So volume is equals to number of moles, 0.083 multiplied by what is the molar gas volume is at RTP, which is 24. Okay, so I can say mole multiplied by 24 decimeter cubic per mole. Mole and mole cancels. What are we going to have as a volume? So kindly multiply. What are we able to find as a volume? Okay, so multiply 24. So 0.083 multiply 24. So I'm able to find 1.99 2 decimeter cubic, which is just the same as 2 decimeter cubic. Let me hear from you what you found. What have you found? Okay, the one who found 19.992, how did you find Ngwila? So I can see PD 1.99, which is just the same as 2, yes. So Ngwila, get to check your answers for your answer. So I'm going to leave with you. I'm going to give you one of the questions. Let me just check my time. Okay. All right. So we might not go expected time, but we are still solving. Let us look at this question. Okay. I'm going to give you a question that you are going to answer at the end of the day. So let us look at this question. Okay. In an experiment to prepare a salt, Helena reacted 3.0 grams of magnesium oxide with 40 centimeter cubic of dilute nitric acid of concentration 2.0 mole per decimeter cubic. Write the balanced chemical equation for the reaction. So balanced equation or balanced chemical equations are the common questions that you are going to find. Okay, so here magnesium oxide. So magnesium oxide, and you know that this is solid. Okay, I guess my ink is visible. Let me just use blue. So magnesium oxide, which is solid, plus what is here? Nitric acid. You see why I told you 4 acids? Okay, so why I told you 4 acids, this time around you are given nitric acid. Okay, nitric acid. Then of course this is aqueous, and you need to know the radicals of the valence of the radicals. So what is going to form here? Magnesium and nitrate react. Magnesium has a valence of 2 and nitrate has a valence of 1. So this one is going to form magnesium then nitrate with a 2 outside, plus this is the base, water, okay, which is liquid. This is aqueous. Okay, is it balanced? So magnesium 1, magnesium 1, oxygen 1, 4. Oxygen this side we have 6. This 2 multiply 3, 6, 7. Okay, so let us put a 2 here in front. So when you put a 2 in front, magnesium 1, oxygen, this is 6, plus 1, 7. Hydrogen 2, nitrogen 2. Nitrogen here 2, magnesium 1, oxygen 7, hydrogen 2. I guess it's a balanced equation. Okay, are we together up to this point? Okay, so calculate the number of moles of magnesium oxide. Calculate the number of moles of magnesium oxide. So how do you calculate number of moles of magnesium oxide? So for number of moles of magnesium oxide, so number of moles of magnesium oxide equal to, here what are we given on magnesium oxide? We are given the mass. So mass given over molar mass. What is the mass given? 3.0 gram. Divide, what is the molar mass of magnesium oxide? So we have magnesium 24. Then of course oxygen 16. I guess that one should be able to give us 60. Is it 40 or 60? 40. Okay, should be able to give us 40. Someone to confirm, 40 moles a gram per mole. Is it giving us 40? 40 gram per mole. When you divide, what are we going to have? So gram and gram cancels. 3 divide 40, what is the answer? What is the answer? 3 divide 40, so should be able to give you 0.0, that is 0.075 more. So this is the number of moles of what? Magnesium oxide. Okay, I guess we are moving at the same pace. Are we moving at the same time? Okay, 0. So Ngwila, you've missed it you've missed it slightly in terms of your numbers. Supposed to be 0.075. Okay. Then of course, what about number of moles of nitric acid? So number of moles of nitric acid, HNO3, equal to 40 centimeters. So here you have volume and concentration. So the volume is 40. We divide by 1000 to make it in decimeter. I guess we should be able to have 0.0, okay, 4 decimeter cubic. 0.04 decimeter cubic. Okay, then multiply by the concentration, which is 2. So concentration is 2 mole per decimeter cubic, multiply by what? 0.04 decimeter cubic, which is equals to what? 0.08. That is more. I guess that is what you've gotten. Okay, I can see Namakao, you've confirmed. Then now, determine the limiting reactant. Limiting reactant, we've just passed through the process of determining. So we just get the number of moles here that we found for magnesium oxide and nitric acid. We divide with the number of moles in front. So for magnesium oxide, there's a 1, so the number maintains. Then for nitric acid, there's a 2 in front, so we divide this one 2, so it's going to be 0.04. that is more. So the one with less number of moles is the limiting reagent, and in this case nitric acid is the limiting reagent. So you can say nitric acid is the limiting reagent. Have you all found nitric acid as a limiting reagent? Have we found nitric acid as a limiting reagent? Have you all found nitric acid as a limiting reagent? What have you found as a limiting reagent? So for me, I found nitric acid as a limiting reagent. Okay, let us answer one more question. Then, of course, the other one I'll leave up to you. I'll leave it up to you. Okay. So excess of zinc metal was added to 200 centimeter cubic of 2m, which is molality. You know that m is mole per decimeter cubic. Write the balanced chemical equation. So even in this one, the first question is write the balanced chemical equation. So zinc, metal, and hydrochloric acid. Let us do it. So let me see, do it. So zinc, which is solid, plus hydrochloric acid, which is aqueous. Metal and acid, what is formed is a salt and hydrogen. So zinc displaces hydrogen, and zinc has a valence of 2, please. So zinc chloride, like that, plus hydrogen gas. Is it balanced? So zinc 1, chlorine, so I put a 2 here, chlorine 2, hydrogen 2, hydrogen 2. So it's a balanced equation. As simple as that. Then number of moles of hydrochloric acid produced in the reaction. So number of moles of hydrochloric acid is equals to, what are you given? The volume and concentration. So concentration and volume. Concentration is 2 mole per decimeter cubic, multiplied by the volume is 200 divided by 1000, it will give us 0.2 decimeter cubic. This one should be able to give us 0.4 moles. Decimeter and decimeter cancels. Confirm? Okay. Okay. Okay, so Jackson, you've gotten right the equation. And of course, PD, you've calculated the correct number of moles. All right. Then the volume of hydrogen gas produced. How do you find the volume of hydrogen gas produced? So to find the volume of hydrogen gas produced, we need number of moles of hydrogen gas. And in this case, they're saying excess zinc. So if zinc is excess, hydrochloric acid was a limiting. So the ratio that you are going to form is for HCl to that of what? Hydrogen gas. Now in front of HCl there's a 2. So 2 moles of HCl produces what? 1 mole of hydrogen. Okay, 1 mole of hydrogen. What is the number of moles of HCl that we found? 0.4 moles of HCl. What about hydrogen? This one's supposed to be hydrogen gas. We cross multiply, so it will be 2 moles X is equals to 0.4 moles. So divide 2. So we're going to have X is equals to, that is divide 2 moles. 2 moles. So more and more will cancel. This one is going to be 0.2 moles of hydrogen gas. Then of course we can find its volume. So volume is equals to number of moles multiplied by molar gas volume. 0.2 mole multiplied by, that is at what? At RTP 24 decimeter cubic per mole. So more and more cancels. 0.2 multiply 24. 0.2 multiply 24. Let me hear from you. What is the answer? What is the answer if you multiply by 24? If you multiply 24, is that the same as 2? It should be 0.48. Is it 0.48 or 4.8? I mean 4.8 decimeter cubic of hydrogen gas. Is it what you found? Okay, 4.8. I can see Willa and P. Okay. Okay. Wow, still have a lot of questions to answer. Okay, so what I can do is so 1, 2. Okay, so let us answer 2 questions. Then, of course, the last one I will leave it up to you. So the other question that we are answering here is that this one came in 2023, I think, GCE. What is a mole? What is a mole? Let me hear from you. What is a mole? What is a mole? What is a mole? So a mole is that amount of substance. Let me say is the amount of substance that contains as many elementary particles as they are in exactly 12 grams of carbon 12 isotope. That is a mole. Okay, so a mole is just the amount of substance that contain as many elementary particles as they are exactly 12 grams of carbon. Now, big question, the concentration of sodium hydroxide solution is 0.25 mole decimeter cubic. Calculate the number of moles of 0.2 decimeter cubic of sodium hydroxide solution contained in 250. Okay, so number of moles of sodium hydroxide, we are using concentration multiplied by volume. So the concentration is 0.25 mole per decimeter cubic. Then of course the volume is 250 divided 1000 should be able to give us 0.250 centimeter cubic. So now what is the answer if you multiply this? What is the answer if you multiply 0.25 multiply 0.25? 0.25 multiply 0.25. I'm able to find 0.0625. Just confirm what you found. This is the number of moles. So the box here, that is where you calculate. So that is what I'm able to find. What have you found? Okay, Pili, we found the same. Now, the C question, a metal ion is extracted from iron ore called hematite in a blast furnace during the reduction reaction using carbon as a reducing agent as shown in the reaction. So as you can see, iron, which is iron oxide, carbon monoxide, and of course that. Calculate the mass of carbon monoxide gas required to reduce. I guess this is 3,200 grams of iron. Okay. Calculate the mass of carbon monoxide required to reduce to 3,200 grams per kilogram of iron. So here we go back to mass. So we are going to find the molar mass of this one. We treat it as the mass, then to this one. Okay? Then of course, what about this one? So what I'm saying is that we are going to form the ratio of iron oxide 2, 3, carbon monoxide. So what is the molar mass of iron? So for iron is 3 oxygen, okay, 16. Then of course iron is 2 of it. So what is the iron in terms of molar mass? For iron should be 56, that I'm seeing here on the periodic table. So 56. So if we are to find this, that is 48. Okay, so be able to check, please. So 2 multiply 56 is giving me 112. So this is 112 plus 16 multiply 3. So 3 multiply 16 is giving me 48. So 48 plus 112. 48 plus 112 is giving me 160. So 160 kg. We are using the units of mass that is given. React with carbon monoxide. We have oxygen 16 and carbon 12, but there's a 3 in front. So this is 28 multiplied by 3. So carbon is 12, oxygen 16. So 3 multiplied by 28, that is 84. So 160 kg of iron react with 84 kilogram of carbon monoxide. What about, here they're saying required to reduce mass of carbon monoxide. What about 3,200 kg of carbon monoxide, iron? How much of carbon monoxide will be required? So this is 160 kg x equal to 84 multiplied by what? I'm just leaving out units for the sake of space. Or let me just put them. 84 kg multiplied by 3,200 kg divide 160 kg divide 160 kg. So x is equals to 0 and 0 cancels, kg and kg cancels. So what I'm remaining here is that is 84 multiply 320 then divide 16. So I'm able to find 1,680 kg. Okay, that is what I'm finding as the mass of carbon monoxide that would be required. What have you found? What have you found? People are quiet. What have you found? So that is the mass of carbon monoxide that will be required. And one of you requested, okay, so Namakwa, you found, okay. I guess people are following. Okay. Okay, so this one, I think I should leave 2 questions because these are just common things that we've done. So look at the question. After some time, I'll be able to flash it or to move to the other question that you have to answer. So this one, answer this question. And also this question. So those that will come after also be able to pause and answer the question. Okay. So this part here as a question. Okay, as a question, as you can see the question. So this one came section C. So the question, you can pause the video please and copy the question as I'm moving. You can pause the video and copy the question. So this is the question that you are going to answer. Okay, so answer the question, and of course instead of posting your answers in the comment section, scan your answers, make a PDF. So make a PDF, then of course send to the number 0976402563. I'll be able to check. So please, if you send photos, I might not be able to check because I can only mark PDF. So that is my WhatsApp line. You can share. I mean, you can share the answers to this number, and of course, I'll be able to mark and to give you a feedback. Okay. So please, this is where we get to end. And for those that are interested to revise with us, even with the time that is remaining, you are free to still WhatsApp this number, and of course, we'll be able to uh, um, yeah, to welcome you as we are revising. So we are going through past papers. That is mathematics, physics, biology, and chemistry. So physics, biology, chemistry, and also mathematics. So it's just 100 kwacha, even with the time that is remaining, because you have almost a month. We revise until you finish writing. So it might be something helpful. And also keep inviting others. There are quite a number of materials that are on this platform. So invite others, make sure that you encourage them to subscribe to the channel. Also go through the recordings that I have. There are quite a number of them. Some of you request the topics that are already here. So start from the scratch. Go through all the videos. You might find even the information that you are lacking. Otherwise, for today we end here. And of course, the next one, I'll still communicate when we are going to have the next one. Otherwise, we can end here.